So before we even start this problem, I want to make sure that we have a good understanding of what it means to count by odd numbers or count by even numbers. So let's say I wanted to count by odd numbers starting at maybe 7. So 7, next odd number. So remember, odd numbers just are numbers that we can't uh, divide, that are not divisible by 2. So 9, 11, 13. We'll stop there for this example. Now, each number in this sequence is odd. And if we notice, counting by odd numbers, I'm just going up by 2 each time. Just like that. 7 to 9 is 2. 9 to 11 is 2. 11 to 13 is 2. Essentially, we're skipping all the even numbers. All right, now let's see what the case is for even numbers. Let's say I wanted to start at, let's say 4. Well, even numbers are just numbers divisible by 2. So the next even number is going to be 6, then 8, then 10, and we'll stop there. And if we look, this is pretty similar to the odd numbers. Every time I move forward, I go up by 2 because we're skipping all of the odd numbers. So every new number in the sequence is 2 higher than the last one. And that's going to be really important when we deal with consecutive number problems. Okay, so I'm going to go ahead and read this problem right here. The sum of 5 consecutive odd numbers is 135. What is the second number in this sequence? Okay, so let's kind of break this problem down a little bit. Now, I'm going to actually start at the end of this where it says is 135. What that means? Well, this whole thing, the sum of 5 consecutive odd numbers, that's going to be equal to 135. That's what is 135 means. So I can go ahead and just start by writing 135 equals. And just start it right there. Okay? Now, the sum of 5 consecutive odd numbers. What I like to do on these problems is just start with the first number. And I say first number because we don't know what that number is. Whenever I have any sort of unknown number, I'm going to just call it a variable. And the easiest variable to use, I'd say, would probably be x. And we're going to say this is the first number in our sequence. Now we got to think back to what we were just talking about. If I'm counting by odd numbers, well, the second number is going to be 2 spaces away from our original number. In other words, our original number x plus 2. So if x was, say, 13, x plus 2 would be 15, the next odd number in the sequence. So x plus 2, that's the second number. But we're not quite done yet. Because this says the sum of 5 consecutive odd numbers. Okay? So our third number, well, it's just going to be our second number plus 2 more. So x plus 2 plus 2, that's just going to be x plus 4. Okay, that's our third number. My fourth number, that's just going to be my third number plus 2 again. In other words, x plus 4 plus 2. So that's x plus 6. Again, we're essentially just skip counting by 2. All right, that is number 4 in our sequence. And our last one is just going to be our fourth number plus another 2. So x plus 6 plus another 2, which would give me x plus 8. Just like that. All right, now what I need to do is go ahead and combine my like terms. So I've got 1, 2, 3, 4, 5 x's. So I'm going to say 135 equals 5x plus something. And then I just have to look at all my just constant terms. So 2 plus 4 is 6, plus 6 is 12, plus 8 is 20. And then look at that. I have myself a nice two-step equation. I can solve for x. I'm just going to subtract 20 from both sides, just like that. I'm going to get 115 equals 5x. Go ahead and divide both sides by 5. Got to maintain that balance. And when I divide 115 by 5, I am going to get, let's see, 23, and 5x divided by 5 is just going to be x. But here's where we have to be a little bit careful. 23 is equal to x. And if I look back at my original kind of equation that I made up here, x is my first number in the series. But the question is asking for what's the second number? And the second number is x plus 2. So in order to find that second number, we have to take our x value of 23 and add 2 to that. So 23 plus 2. That is going to get us 25, which is going to be our answer. That's the second number in the sequence. And if you wanted to check that, you could just you could put in 23 in for all the x values and add it up. And I'll do that right now just to check. So we'll do 23 plus 23 plus 2 plus 23 plus 4 plus 23 plus 6 plus 23 plus 8, and that gives us 135. So we should get an answer of 25 for our second number. Let's go ahead and check that. All right, looks good. Let's move right along and do a second one. All right. The sum of 6 consecutive odd numbers is 204. What is the fourth number in this sequence? All right, let's go ahead and check this out. So 6 consecutive odd numbers is going to be equal to 204. Okay, so 204 equals x. We're going to just start with x just like before. We're counting by odd numbers, so that is our first term, plus x plus 2 That's our second term, plus x plus 4. Again, we're just skip counting by 2. That's all that counting by odd numbers or even numbers is. So that's number 3. Let's do another one here. Our fourth term is going to be our third term plus 2. So x plus 6. It's a little bit of a longer one. Plus our fifth term is going to be x plus 8. In other words, term 4 plus 2. Okay, that is term number 5. And since this is 6 consecutive odd numbers, we got to do one more. So it's going to be term 5 plus 2. So x plus 8 plus 2 is going to be x plus 10. Okay, that is term number 6 right there. Now let's go ahead and combine our like terms. So I have 1, 2, 3, 4, 5, 6 terms. Means I have 6 x's. So we're going to do 204 equals 6x plus our constant terms. So let's add those constant terms. 2 plus 4 is 6, plus 6 is 12, plus 8 is 20, plus 10 is 30. Okay. Have a two-step equation just like before. I'm going to get rid of that constant right there. So it's a plus 30. I'm going to subtract 30 from both sides, just like that. So that's going to cancel out right there. And on our other side, we're going to get 204 minus 30 is 174 equals 6x. X is being multiplied by 6, so we'll divide both sides by 6. We'll get 29 equals x. Okay, now, just like on the last problem, we have to be careful because 29 is not the solution to this problem because we are looking for the fourth number in the sequence, and x is the first number. And that's really why I like to label the terms and why I use parentheses like this. It makes it a little bit easier to stay organized. So my fourth term is actually x plus 6. So let's go ahead and take our x value down there and add 6 to it. So 29 plus 6. That's going to get us 35. Just like that. Go ahead and enter that in. All right, here we go. This will be the last one. I just want to make sure we get one with even numbers to show it's pretty much the same method. Okay, the sum of 3 consecutive even numbers is 132. What is the third number in this sequence? Okay, well, we know that sum is equal to 132. I'm going to go ahead and put that over here to start. 132 equals, all right, let's see, the sum of 3 consecutive even numbers. So we're going to start off just like before, x. That's our first number. Doesn't matter what it is, we just know that it's even. All right, that is number 1 in the sequence. Now we're counting by 2's. We're skip counting, right? Doesn't matter if it's even or odd. So the second number is going to be whatever my first number is plus 2. In other words, x plus 2. And if we think about this in terms of numbers we know, it kind of makes sense. So let's say the first number was 14, right? 14. The next even number is going to be 16. And 16 is 2 more than 14. All right, so there's our second term. Our third term is just going to be our second term plus another 2. In other words, x plus 2 plus another 2, or x plus 4. Just like that. All right. Now let's combine our like terms. I have 1, 2, 3 x's. I'm going to actually do it right over here because we have a little bit more room this time. So 132 equals 1, 2, 3, 3x plus, we're going to add our constant terms here. So 2 plus 4 is 6. Okay, just like that. Now we have ourselves a two-step equation. Subtract 6 from both sides. 6 is over here, or 6 minus 6, that's going to cancel. Then we're going to get 132 minus 6, that is 126. Just like that, 126 equals 3x. Divide both sides by 3. And I get 42 equals x. Now let's check the problem to see what they're looking for. What is the third number in the sequence? Okay, so 42. 42 is our first number in the sequence. It's just x. Our third number is x plus 4. So let's do our x, which is 42, plus 4. And that'll get us 46. So that means the third number in our series is 46. And it should mean that 42 plus 44 plus 46 is equal to 132. And I'm going to just check that real quick. So 42 plus 44, that's 86, plus 46, that gets us 132. So our third number is 46. All right. And you know what? I said the third question was going to be the last one, but might as well finish it out here with a fourth one. All right, let's clear this. The sum of 4 consecutive integers is 198. Okay, so this I'm glad we have this one because this is just a little bit different than the last 3. So integers, when we are counting by integers, we are just counting by ones, right? So an example of that might be just going, -2 to -1 to 0 to 1. Each time, I'm just going up by 1. Okay, so that language in there is important. That's why we got to make sure we read the questions fully. All right, so counting by ones. Just erase that. There we go. All right, but we can use our similar strategies to what we used on the other questions. This says it is 198. We know is just means equals. So we'll say 198 equals, and we're looking for the sum of 4 consecutive integers. Let's start with our first one. Just like before, we'll start it with x. X is going to be the first number in the sequence. Our second number, since we're just counting up by ones, our second number is going to be just our first number plus 1. In other words, x plus 1. There is 2. Our third number, that is going to be our second number plus another 1. We're just counting up by ones. Okay, so it's going to be x plus 1 plus another 1, or x plus 2. That's our third number in our sequence. And we're looking for the sum of 4 consecutive integers. So we got to get one more term here. And it's just going to be our third term plus another 1. Or x plus 2 plus another 1, x plus 3. And that is our fourth term. Let's go ahead and simplify this, combine our like terms. So 198 equals, so we've got 1, 2, 3, 4 x's, 4x. And our constant terms, we've got 1 plus 2 is 3, plus 3 is 6. So we'll go ahead and add 6. Then it's just a matter of solving for x. So we'll subtract 6 from both sides. Those 6's are 6 minus 6, that'll cancel. 198 minus 6 gives us 192 equals 4x. All right, got to get x on its own, so we'll divide both sides by 4. Just like that. And 4 divided by 4, well, that is going to be, that'll cancel to 1. We'll just get x on its own. 192 divided by 4, that's going to get us 48 equals x. And one last time, we are looking for the fourth number, not the first number. And our fourth number is equal to x plus 3. So let's do 48 plus 3. That gets us 51. In other words, it should be true that 48 plus 49 plus 50 plus 51 is equal to 198. And I'm going to just check it on my calculator real quick to make sure that's the case. So 48 plus 49 is 97, plus 50 is 147, plus 51 gets us 198. So our answer is going to be 51. And the key to this last one was just recognizing that we are counting by integers, not by odd or even numbers. So if you count by odd or even numbers, you're going to be counting by 2. If you're counting just integers or just whole numbers, you're going to be counting by 1.